Hello my friends, and welcome back to the You Can Do TV channel. Selecting the right coconut shells is a critical first step in establishing a coconut-based enterprise. The process begins with sourcing mature coconuts, typically aged 10 to 12 months, as they provide strong, dense shells ideal for further processing. Freshness and quality are essential. Shells must be free from cracks, mold, or insect damage. Once harvested, coconuts are dehusked to reveal the hard shell. The coconut water and flesh are removed, ensuring the shell remains intact. Skilled workers or specialized cutting machines split the shells, after which they are cleaned thoroughly to remove residual husk fibers and inner pith. For industries such as activated carbon production, handicrafts, or shell-based charcoal, shells are sorted by size, thickness, and density. Uniformity in size improves efficiency in downstream processes, while thickness and hardness determine durability and yield. After sorting and drying, the selected coconut shells are carefully transported to loading areas. Workers or conveyor systems move the shells in bulk, ensuring minimal damage during handling. The shells are then loaded onto trucks, either manually with baskets and sacks or using mechanized loaders, depending on volume and scale. A meticulous shell selection process ensures consistent raw materials, reduces waste, and maximizes profitability, laying the groundwork for producing high-value coconut products for domestic and export markets. In Sri Lanka's coconut heartlands, the journey of Ceylon cocoa peat starts with the husk. Once separated from the nut, the coarse coconut fibers are sprayed with water to soften and cleanse them. These hydrated fibers are then ground into a fine, earthy powder, the precious cocoa pith, then sun-dried until it reaches the perfect balance of moisture and delivery to factory. To ensure purity, the pith is thoroughly tested to remove salts and impurities. Next, it is compressed into compact blocks, preserving its natural water retention and soil aerating qualities. In your garden, a splash of water transforms these blocks into fluffy, nutrient-rich mulch, ready to blanket your soil, lock in moisture, and nurture plant roots. The long, strong fibers are set aside for rope making, a traditional craft that has supported island communities for generations. This gentle, chemical-free process turns coconut husks into an eco-friendly treasure that keeps your garden lush, resilient, and naturally beautiful. Coconut husks are an abundant and renewable resource widely used in sustainable industries. To prepare the fibers, the husks are soaked in fresh water for 4 to 6 weeks, which softens them and makes extraction easier. After soaking, the fibers are mechanically extracted and cleaned. These fibers are then pressed tightly into blocks or mats, forming a durable and eco-friendly product. Finally, the compressed coconut fiber blocks are carefully packaged for distribution. This sustainable process transforms coconut husks, a renewable resource, into versatile materials used in gardening, construction, and insulation. Harvested from coconut palm blossoms, organic road coconut nectar is a low-glycemic, nutrient-rich sweetener, packed with B vitamins, minerals, and 17 amino acids. Twice daily, sap is collected, preserved with mangosteen juice, then gently boiled to a rich caramel flavor with a hint of lemon. perfect for drizzling, cooking, or creating healthy desserts. Sri Lanka, a tropical island nation, is renowned as one of the world's foremost producers of premium quality coconuts. Coco Ceylon Exports Private Limited specializes in producing extra virgin coconut oil from fresh coconuts grown organically without the use of chemical fertilizers. Production begins with peeling the husk, cracking the shell, and removing the thin brown skin. The white coconut meat is thoroughly washed several times under the supervision of quality control experts, then finely cut into flakes. These flakes undergo careful dehydration to remove 100% of moisture while preserving natural freshness. Advanced extraction machinery produces 100% pure, crystal-clear organic coconut oil, known for its health-enhancing properties and potential disease prevention benefits. Every stage of processing is monitored to maintain the highest quality standards. The finished oil is tested, approved, and filled into sterilized bottles under strict hygiene protocols. Each bottle is securely packed to ensure safe transport and long shelf life. Marketed under the Coco brand, this organic coconut oil is distributed worldwide, bringing the natural purity, freshness, and nutritional richness of Sri Lankan coconuts to global consumers. Located in the heart of the Indian Ocean, Sri Lanka is renowned for its thriving coconut industry and excellence in producing coir-based value-added products. Coco Lanka Private Limited stands as a leading manufacturer and direct exporter of premium organic coconut husk-based growing media, serving modern and protected agriculture worldwide. Production commences with the extraction of husks from mature coconuts, sourced from a dedicated supplier network under strict total quality management (TQM) protocols. High priority is placed on selecting premium raw materials. Once collected, the dehusked coconuts are tested, hand-picked, and processed through decorticator machines to extract fibers and cocoa peat, while husks are cut into chips. Subsequent stages involve washing, drying, and grading the cocoa peat under controlled conditions to prevent contamination from sand, weeds, or pathogens. When optimal moisture levels are reached, materials undergo laboratory testing before entering the cleaning, sieving, and blending phases. The blended mixture, comprising cocoa peat, fiber, chips, and pith, is then compressed to customer specifications. Finished products are rigorously tested for quality, packed under ISPM standards, and shipped globally. Consistent quality, eco-friendliness, and reliable performance for sustainable agricultural growth. At Haripad Coir Cluster, the fiber cleaning process ensures removal of impurities to achieve consistent quality. Premium coir fibers are sourced, thoroughly washed, and dried to preserve natural strength. These fibers are then combed and aligned for uniform texture, meeting industrial-grade standards. At Vicombe Coir, the processed fibers are twisted and braided into strong, durable ropes. This traditional rope-making process combines skilled craftsmanship with precision equipment, delivering high-tensile coir ropes suitable for marine, agricultural, and construction applications. The use of coir geotextiles in rural road construction offers a technically robust and eco-friendly solution for reinforcing subgrade layers. Made from coconut husk fibers, coir geotextiles provide high tensile strength, elongation of around 30%, and excellent permeability, allowing water to pass through while retaining soil particles. In road structures, they are typically placed above the subgrade, functioning both as a reinforcement and drainage medium. Installation begins with preparing and compacting the subgrade to 100% density using optimal moisture content, verified through methods like the sand replacement test. Coir geotextiles are rolled out with proper overlaps, folds removed, and fixed using clamps or cable ties at regular intervals. In curves, adjustments are made to ensure uniform coverage. A granular subbase, GSB, is then placed over the fabric, spread evenly, and compacted to the required thickness and camber. Base layers of graded aggregates follow, each compacted and bound with screening material, binder earth, or bitumen emulsions depending on the layer. Finally, a bituminous surfacing such as a pre-mixed chip seal is applied. Coir geotextiles have a service life of over 5 years, sufficient for the pavement layers to stabilize and gain strength. Compared to synthetic alternatives, they are resistant to saline water, degrade naturally without environmental harm, and are cost-effective due to local material availability. This technology reduces aggregate contamination, improves load distribution, and extends pavement life while lowering overall construction costs. Coco Goods combines advanced technology with traditional coconut processing in Vietnam's Mekong Delta. Coconuts are harvested at optimal maturity and transported quickly to processing plants to maintain freshness. The raw material undergoes preliminary cleaning and quality inspection before entering production lines. Advanced mechanical extraction separates coconut water, milk, cream, and fiber. Cold pressing techniques are used to produce virgin coconut oil, preserving nutrients and natural properties. Filtration systems ensure purity and clarity of liquid products. Processing facilities use modern equipment to handle large volumes while maintaining hygienic conditions compliant with international food safety standards such as ISO 22000 and HACCP. Packaging is automated for efficiency and sterility, reducing contamination risk. Continuous monitoring and testing ensure product consistency and quality throughout production. Organic certification standards are met through controlled cultivation and handling practices, including soil management and pesticide control. Sustainable supply chain management integrates farm-level data with processing workflows to optimize yield and reduce waste. This technical integration of agricultural sourcing, precise mechanical processing, and rigorous quality control enables the production of high-grade coconut-based products for global distribution. Straw bale load-bearing construction is a sustainable and energy-efficient building method that uses straw bales as the primary structural component of walls. This technique combines traditional craftsmanship with modern engineering principles to create buildings that are both environmentally friendly and structurally sound. The process begins with constructing a strong moisture-resistant foundation, often made from concrete or stone, which elevates the straw bales above ground level to prevent water damage. Straw bales are then carefully stacked in courses, either laid flat or on edge, depending on structural requirements. They are tightly compacted and secured using wooden stakes, rebar, or wires to ensure stability and load distribution. Straw bales are carefully arranged and stacked using a crane to ensure precise placement and efficient handling, especially for large-scale construction projects. Once positioned, the bales are tightly secured together by driving wooden stakes through them. These stakes act as fasteners, firmly holding the bales in place and preventing any shifting or movement over time. This technique not only stabilizes the entire structure, but also helps maintain the integrity and alignment of the walls. Straw bales provide excellent insulation due to their high thermal resistance, significantly reducing heating and cooling demands. Straw bale load-bearing construction is particularly suited for rural or temperate climates and promotes the use of renewable, locally sourced materials. Its low embodied energy and strong insulation properties contribute to reducing overall environmental impact, making it an excellent choice for sustainable and energy-efficient buildings. Constructing an 850 square meters load-bearing straw bale building with one floor in just 3 months is an ambitious but achievable project with careful planning, efficient teamwork, and the right techniques. The process begins with site preparation and foundation work, which provides a stable base for the straw bale walls. Typically, a raised foundation or a reinforced concrete slab is laid to protect the straw bales from moisture. The construction process begins with erecting the main structural frame of the house, ensuring a strong and stable skeleton for the building. Once the frame is securely in place, concrete is poured to reinforce the foundation and key structural elements, providing additional strength and durability. After the concrete is fully cured, the straw bales are carefully positioned and stacked onto the frame to form the walls. Straw bales are delivered and stacked to form the structural walls. Using a crane or forklift greatly speeds up the process, allowing large bales to be placed quickly and precisely. The bales are tightly compressed and secured together, using wooden stakes or metal rods, which prevent shifting and ensure structural stability. The roof framework is prefabricated off-site and then lifted into place using a crane. Once the frame is securely positioned, a waterproof membrane is installed to protect against moisture. Finally, the roof is completed by laying tiles, providing both durability and an attractive finish. This method speeds up construction and ensures precise assembly for a weather-resistant roof. To meet the deadline, multiple crews work in parallel, one handling wall construction, another focusing on foundation and flooring, and a third on roofing. In summary, combining modern machinery, traditional straw bale techniques, and precise project management makes it possible to construct a sustainable, durable, and energy-efficient straw bale building of this size within 3 months. The Dome Coupole per Abitare project was developed as part of the 2011 experimental educational construction site by students of Project Laboratory 2 at the Faculty of Architecture and trainees from the Syracuse Building School. Using traditional construction elements such as arches, vaults, and brick domes, the students explored innovative applications of materials and traditional building technologies. This hands-on experience allowed them to adopt and adapt techniques inspired by Fabrizio Carola's work in Africa, blending heritage craftsmanship with contemporary design approaches. The project highlights the potential of brick domes and vaulted structures as sustainable and creative architectural solutions. A Sri Lankan pioneer high-quality coconut husk-based growing media made from processed coir pith, fiber and chips. The process involves dehusking, cutting, fiber extraction, washing, drying, grading, and compressing under controlled parameters. Advanced machinery ensures uniform particle size, optimal moisture content, and low electrical conductivity. Strict quality control includes sieving to remove impurities, mechanical mixing, and multiple laboratory tests for pH, EC, and physical structure. The final substrates are designed for hydroponics, propagation, and professional horticulture, offering excellent water retention, aeration, and durability while meeting international agricultural standards. For the Kochi Spice Coast Marathon 2022, coconut husk fibers, known as the golden fiber, were processed into coir-needled felt sheets. These sheets were cut, layered, and hydraulically pressed into eco-friendly metals, showcasing sustainable innovation rooted in coastal tradition. At the Modular Coir cluster, the production line features a 7 HP Coir Bale opener with a capacity of 2,000 kilograms per 8-hour shift, followed by a 3.5 HP non-woven coir needle felt machine equipped with an electric control panel. This system produces 102-inch wide coir felt using vertical punching technology, a downstroke single-stroke punching unit, and a 3-stage auto feeder. With an output of 380 to 600 square meters per hour and adjustable density from 500 GSM to 1,200 GSM, the durable felt is ideal for geotechnical and horticultural applications. Combining traditional craftsmanship with modern machinery, the cluster supports a range of manufacturing processes from yarn preparation to finished goods. In the Polymer Coir cluster, production begins with copse winding, preparing coir yarn for further processes. Geotextiles are manufactured using specialized looms, supported by a thermic fluid heater to maintain optimal processing temperatures. The mixing process ensures uniform blending of fibers before yarn feeding into machines. Precision cutting heads shape the material into desired sizes, maintaining accuracy and consistency. Finally, the finished mats are produced, meeting high standards for durability. From an organic coconut grove in Sri Lanka, coconuts are peeled, finely cut, air-dried, cold-pressed, filtered, and bottled to produce pure, nutrient-rich virgin coconut oil. The Optima's H88 for efficient mechanized paving. Its reliability supports large-scale infrastructure development with minimal manual effort. The machine's shipping dimensions are 350 by 950 millimeters. The machine is capable of lifting arrows with a load of 700 kilograms. This advanced machine ensures precise, fast, and uniform laying of paving stones, improving productivity and quality in road and surface construction projects. The Gablock concept enables anyone, whether experienced or not, to build their own house using an innovative system. After adapting the architect's plans, a kit of insulated wood and EPS blocks is delivered to the site. These lightweight blocks, weighing about 7 kilograms each, fit together perfectly to form the structure. On the first day of construction, the initial layers of blocks are placed with precise assembly, similar to furniture building. Each step is guided by a detailed plan showing the exact position of every block. One of the key advantages of Gablock construction is the ability to predefine critical measurements such as window and door openings. The blocks come in 3 versions and 3 sizes, enabling precise dimension control throughout the building process. This method not only simplifies construction but also enhances the overall quality and predictability of the project. The 3-way grid shell is a geodesic timber structure made of 12 mm birch plywood planks, designed for open-air classrooms at ETSAV. It features 3 families of pseudo-geodesic curves, forming a lightweight, ultra-thin shell. Constructed from straight, planar planks without waste, the design relies on precise hole positioning for assembly. Students manage the entire process, including design, numerical fabrication, and construction, under guidance from international experts in structural design, wood construction, and computational geometry. Python 5000 R1000 Emergency Pothole Repair Unit delivers fast, safe on-site restoration. Rapid deployment, one-touch drive mode, 5-step repair, surface cleaning, tack coat application, asphalt placement, leveling, and roller compaction. Benefits include reduced work time, efficient crew deployment, improved worker safety, intuitive operation, and low-maintenance design for urban road maintenance reliability. K31 APS is a soil stabilization technology that uses a special mixture of polymers. K31 APS road construction uses a tractor with a rotavator for uniform mixing, followed by vibrating compactors and double steel rollers for a smooth, perfect finish. No cement, lime, or stones required. Concrete roller screeds from Curb Roller MFG revolutionize concrete shaping worldwide. With tools like the Curb Roller, Hydra Screed, Bat Screed, and Eel Screed, contractors achieve faster production, versatile applications, and superior quality without heavy, costly equipment. Perfect for flatwork, flumes, curbs, and gutters. The Coco GP4 and TC5600 deliver advanced concrete paving and texturing solutions, ensuring precision, high productivity, and superior surface finishes for large-scale infrastructure and highway construction projects. Circulen Q creates prefabricated modular paving elements for bike paths, parking spaces, and walkways. Made from recycled plastics, they allow rainwater infiltration, reduce waste, and can be reused elsewhere when layouts change. Durable, quick to install, and 100% circular, paving the way for greener, smarter infrastructure. Potholes may start small, but left untreated, they grow into costly road damage. Chipfill offers a fast, lasting fix. Begin by sweeping the surface clean, then heat the pothole with a torch. Pour in Chipfill, the specially designed thermoplastic for cracks and small holes, 15 to 20 centimeters. Reheat until it melts and bonds. Sprinkle anti-slip powder, and you're done. Its hot applied formula fuses with the asphalt's bitumen, creating a stronger seal than cold repair systems and preventing further deterioration. Gap Mastic and Gap Patch from Maxwell Products provide a permanent, high-performance solution for a wide range of pavement repair needs. These advanced materials are engineered to restore structural integrity and extend the life of asphalt surfaces by addressing wide cracks, fatigue cracking in alligatored areas, raveling, depressions, potholes, and deterioration around embedded structures such as gutters, drains, and manholes. The mastic material bonds effectively with the existing pavement, creating a seamless, watertight surface that resists further damage. Gap patch is designed for quick application, enabling efficient repairs without compromising quality. Field-proven in various climates, including Nebraska, Utah, and Minnesota, these products excel in shoulder repair, wide crack filling, drain restoration, and surface leveling. By integrating gap mastic and gap patch into maintenance programs, pavement professionals achieve durable, cost-effective results for long-term infrastructure preservation. Picture a flawless, durable surface, crafted by your own hands. With Morphe, the two-component resin from Gevo Markingas, it's within reach. Prepare the surface, mask the edges, then blend the resin and hardener into a smooth, even mix. Spread it with a wide-notched trowel, sprinkle your aggregates, marble for elegance, bauxite for unmatched slip resistance, and let the magic set. Remove the tape before full curing. Sweep away the excess after drying. Morphe delivers performance, durability, and the pride of a perfect finish. Building a Lancaster log cabin takes less than 10 days, thanks to precise preparation and skilled craftsmanship. Before construction begins, rough pine timbers are processed in the log shop. Edges are smoothed, tongues and grooves are cut for tight seals, and logs are notched and drilled for wiring. These logs are bundled into kits, ready for assembly. Construction starts with attaching floor joists and installing rough plumbing and electrical systems. Real wood flooring, insulated with styrofoam and sealed with spray foam and caulk, ensures durability and comfort. Walls are stacked like Lincoln logs, with weather stripping and log screws for strength and weather protection. Wiring runs inside the logs for a clean finish. By day 4, railings, doors, and trim are installed. Sanding and caulking prepare surfaces for finishing, where polyurethane and stain protect and beautify the wood. Kitchens and bathrooms are fitted with top-quality fixtures, and electrical work is completed. On the final days, metal roofs and insulated windows are installed for lasting protection and energy efficiency. After a thorough inspection and cleaning, the cabins are ready to be delivered and enjoyed. The plant in Prachovice is one of the largest and most advanced production facilities in the Czech Republic. Raw materials are sourced directly from an adjacent open-pit quarry, which contains various rock types such as high CaO white crystalline limestone and graphite-bearing shales. After extraction, the rock is initially crushed using hammer and jaw crushers, then transported via conveyor belts to a pre-homogenization stockpile. Here, the material is layered to ensure uniform chemical composition before entering the preheating and rotary kiln calcination stages. A modern quality control system continuously monitors the raw mix, ensuring precise chemical consistency and optimal clinker formation. The resulting high-quality clinker is then finely ground into finished cement, ready for distribution. Different applications require different concrete formulations. Let's explore some specialized variants. The preparation of drainage plastic concrete involves mixing epoxy resin with specified aggregates to create a durable, porous material. First, the epoxy resin is measured and mixed thoroughly according to technical specifications. Then, the prescribed aggregate, typically clean, well-graded gravel or crushed stone, is gradually added to the resin while continuously stirring to ensure uniform coating of the particles. The mixture must achieve the right consistency to maintain permeability and mechanical strength. Once mixed, the plastic concrete is promptly placed and compacted in the designated drainage areas to facilitate water flow while providing structural support. Proper curing is essential to achieve optimal performance. This specialized concrete allows for water drainage while maintaining structural support, a perfect example of how concrete formulations can be tailored to specific needs. Beton Fix is a two-component chemical system based on polyester resins for fast concrete repairs. It is used to fix cracks, joints, edges, and corners of damaged concrete, stone, and masonry. Ideal for pothole repairs, stair renovation, or as an adhesive for bonding to stone or masonry elements. For more substantial construction projects, concrete isn't just poured, but sometimes sprayed with precision. The qualification panel demonstrates the application of wet mix shotcrete using the bench method by a certified nozzleman. The bench is formed at an approximate 45-degree angle, providing a stable base for subsequent layers. Shotcrete is then applied perpendicular to the previously placed material to minimize rebound, shadowing, and encapsulation voids. The nozzleman continuously adjusts the standoff distance and nozzle angle to maintain a consistent receiving surface and ensure uniform compaction. Proper technique facilitates rearward material buildup around the reinforcing bars, avoiding accumulation at the front face. Bar deformations remain visible until full encapsulation occurs, confirming adequate coverage and consolidation. Structural applications, concrete has evolved into an aesthetic medium as well. Let's examine some decorative approaches. The process of constructing a decorative wall using Jaeger architectural concrete in the Verona color begins with careful surface preparation. The wall must be cleaned of dust, grease, and any old paint layers, then primed with a dedicated bonding agent to ensure proper adhesion. The architectural concrete is applied using a stainless steel trowel. The first layer is spread evenly and allowed to dry for 4 to 6 hours before the second layer is applied to build texture and depth. During the finishing stage, the craftsman uses troweling techniques to create natural, concrete-like patterns and textures. Once fully dry, a protective topcoat may be applied to enhance durability, water resistance, and stain protection. The Verona color offers a refined medium gray tone, ideal for modern, industrial, or minimalist interior spaces. This process not only delivers a durable surface, but also adds visual character and a sophisticated concrete finish to any wall. An exclusive is a modern decorative plaster that brings an industrial yet elegant aesthetic to interior walls. The application process begins with thoroughly scraping and cleaning the wall, followed by primer application. The plaster is mixed at a ratio of 1 kilogram compound to 360 milliliters water and spread across the surface to form a leveling base coat. After 24 hours of drying, a second decorative layer is applied. Patterns and textures are created using a trowel, then smoothed after 15 to 30 minutes to achieve the desired concrete appearance. After another 24 hours, a highlighting coat, made by mixing components 3A and 3B, is applied to enhance the final tone, available in shades like concrete gray or ivory. Construction often requires innovative approaches to challenges. Let's look at some construction solutions. Chemical anchoring in hollow materials requires proper preparation and application. First, a hole is drilled and cleaned using a brush. For hollow substrates, a plastic or metal sleeve is inserted to contain the chemical resin. The hole must be completely filled with chemical anchor resin before inserting the anchor rod with a rotating motion. This ensures strong bonding without expansion pressure. Metal sleeves require accurate length adjustment for professional applications. Curing time ranges from 15 to 180 minutes, depending on temperature. Chemical anchors are suitable for both interior and exterior use, providing secure and reliable anchoring in various construction environments. Dealing with cracks in your walls or ceilings, a reliable solution is using Decorative smoothing compound in combination with Micros fiberglass mesh. This system offers a strong, flexible reinforcement that helps prevent future cracking. Before beginning the repair, make sure the surface is clean and properly primed to improve adhesion. Then, apply the first full coat of Decorative across the entire surface and immediately embed the Micros mesh, commonly known as reinforcing fabric or scrim, into the wet compound. Smooth it out evenly and cover with a second layer of compound once dry. This method ensures a seamless, crack-free finish. This is how to prepare your surface and how to properly apply both the mesh and compound. It also highlights common mistakes to avoid, such as poor overlap, uneven embedding, or inadequate surface preparation, which can compromise the final result. For interior construction, lightweight materials like aerated concrete offer significant advantages. Video demonstrates the professional construction of a non-load-bearing interior wall using Yutong aerated concrete blocks and thin bed mortar. The process is divided into 5 main steps: materials, preparation, laying the first course, laying additional courses, and installing lintels. Essential materials include Yutong blocks, thin bed mortar, a measuring bucket, aerated concrete saw, saw guide, string line, wall connectors, rasp, trowels, level, and rubber mallet. The substrate must first be leveled and cleaned. Mortar is mixed according to the manufacturer's instructions and left to rest before remixing. The wall's layout is marked, and a plastic slip membrane is placed to absorb slab movement. Irregular surfaces are smoothed with a rasp. The first course is laid in standard mortar to compensate for unevenness, with each block aligned using a level and rubber mallet. Subsequent courses are laid with thin bed mortar, ensuring staggered joints. Blocks are cut to size with a saw and guide. Wall connectors, like expansion nails, ensure secure attachment to adjacent structures. Lintels made from the same material provide consistent construction and are installed with fully mortared bed and head joints. Final adjustments are made using leveling tools, and any surface defects are repaired with Yutong filler mortar. For the top connection, elastic joint foam is recommended for flexibility and crack prevention. Modern construction often integrates heating systems directly into the structure. Groundbreaking roads demonstrate the K31 APS soil stabilizers' advanced military-grade formulation, engineered for superior soil bonding, optimal compaction density, and extended load-bearing capacity, ensuring long-term performance in demanding infrastructure applications. To install a wet underfloor heating system, begin by leveling the concrete subfloor and fitting edge insulation around the walls. Lay insulation sheets, sealing all joints, and apply a plastic membrane if using wet screed. Fix the manifold on the wall and mark areas not to be heated. Lay the pipework starting from outer walls inward, spacing pipes 200 mm apart. Connect circuits to the manifold, fill them with water, and flush out air. Test the system at 6 bars pressure to check for leaks. Finally, pour screed while pipes remain pressurized. Let the screed dry fully before connecting the boiler and finishing the floor. CD400 is a specialized machine designed for efficient clipping and declipping of pandroll FE clips during rail maintenance. It automates the secure fastening and removal of these resilient, elastic clips, which are crucial for holding rails firmly to sleepers. The machine's precision ensures minimal track disturbance and enhances safety by reducing manual handling. Its operation speeds up maintenance tasks, improving overall productivity and reliability in railway track upkeep. R24 Matissa Ballast Regulator, operated by Colas Rail, is a high-output machine specifically designed for the construction and maintenance of high-speed railway lines. Mounted on bogies, the R24 features a hopper with a base capacity of 10 cubic meters, which can be expanded to 13 cubic meters, allowing for the effective recovery of excess ballast and its redistribution to areas with low ballast density. This capability ensures optimal ballast profile and track stability, which are critical for high-speed operations. Equipped with adjustable blades and advanced control systems, the R24 precisely shapes and levels the ballast, maintaining the required track geometry. Its robust design supports continuous, efficient operation, reducing the need for extended track possessions and minimizing downtime. By automating ballast regulation tasks, the R24 improves maintenance productivity, enhances safety for maintenance crews, and ensures compliance with stringent standards for high-speed rail infrastructure. This makes it an essential asset for modern railway maintenance programs focused on durability and performance. All tasks, removing, shifting rows, individually repositioning, cleaning, and stacking 12 concrete tiles, are efficiently performed with one vacuum system in a single machine. During the COVID-19 pandemic, the Warrington Grade Separation Project employed strict safety measures including virus testing, face coverings, and temperature checks. On the 16th of January 2021, a 9-day closure of the East Coast Main Line began to install a 155 meters curved box jack tunnel, an unprecedented method in UK rail construction. Over 11,000 cubic meters of earth was excavated, and the 11,000-ton concrete box was pushed into position using hydraulic jacks. More than 450 workers contributed to the operation. After 4 days of jacking and infrastructure reinstatement, the railway was safely returned to service on the 25th of January 2021, prioritizing passenger needs. The Power Curber 5700 C-Max delivers robust crawler steering, added torque, and multiple vibrator circuits, enabling precise pouring of barriers up to 8 feet high and paving widths of 12 feet. £130 million capacity enhancement project between Kettering and Corby, executed by Network Rail, forms a critical component of the Midland Main Line upgrade. Initiated in 2014, the scheme involved the installation of 21 kilometers of track, comprising 12 kilometers of new dual track and 9 kilometers of renewals, alongside significant infrastructure enhancements. These included the structural strengthening of 14 bridges and viaducts, installation of 4 kilometers of new drainage systems, stabilization of 15 kilometers of railway embankment, and deployment of 73 kilometers of new cabling. The project enables higher line speeds, increased from 60 to 90 miles per hour, eliminates temporary speed restrictions, and improves operational resilience. It also facilitates future electrification, increased freight handling capacity, and supports up to 5 trains per hour in each direction. Let's return to bridge construction with a noteworthy example that showcases precast concrete solutions. On March 1, 2017, Concrete Matters utilized heavy-duty cranes to install a Contact BEBO E54T twin-leaf precast concrete bridge at the new Fort Mill High School No. 3. The crane-assisted placement of the large precast elements enabled precise alignment, reduced on-site construction time, and ensured structural integrity in this key infrastructure project. Finally, let's look at how concrete and construction technologies contribute to urban beautification. Dahlia SDOKFT recently completed the installation of their 20th flower basket unit, a specialized planter basket system designed for urban and public green spaces. The installation process included site preparation, soil enrichment, and the secure installation of the step structure. Using manual positioning, the unit was placed precisely according to the landscape design requirements. The modular design allows for efficient water retention and aeration of plant roots, promoting healthy plant growth. This landmark installation reflects the company's ongoing commitment to sustainable urban greening solutions and effective gardening practices, enhancing both the functionality and aesthetics of shared spaces. Slope grid swale effectively controls stormwater by locking aggregates in place, preventing washouts on steep, gravel roads. Its secure grid system channels water, stabilizes slopes, and reduces maintenance, saving costs after heavy mountain rainfalls. Of the hot mix asphalt HMA paving quality control process focuses on paving operations, covering surface preparation, material handling, paving equipment procedures, and quality inspections. Prior to paving, the underlying surface, whether a newly constructed base, repaired concrete, or milled asphalt, must be clean, free from debris, and swept using mechanical brooms or vacuum trucks, especially in urban areas. All cracks, joints, and surface irregularities must be blown clean using compressed air. A tack coat is then uniformly applied to enhance the bond between the existing layer and the new HMA lift. Transporting HMA from the mixing plant to the site requires strict temperature control. The mix must be delivered at temperatures above 250 degrees Fahrenheit and within plus or minus 20 degrees Fahrenheit of the target mixing temperature. Trucks must be clean, tightly sealed, and covered with tarps to prevent heat loss. Diesel fuel must not be used as a release agent, as it compromises the asphalt's performance. Upon arrival, trucks are carefully guided to the paver to prevent mechanical damage or surface disturbance. The paving process typically includes base, leveling, and surface lifts. The paver must be equipped with an automatic screed control system that adjusts transverse slope and elevation according to the design profile. Paving begins at the butt joint, and the screed must be preheated to prevent material buildup and ensure a smooth mat. Paving speed must match the output capacity of the asphalt plant, and the availability of delivery trucks to ensure continuous operation and avoid surface irregularities due to stoppages. During paving, the HMA is fed into the paver's hopper, conveyed by slat conveyors, and passed through flow gates that control the material quantity before reaching the auger. The auger distributes the mix uniformly ahead of the screed. Ultrasonic sensors monitor and adjust material levels to maintain consistency. Longitudinal joints between adjacent paving lanes are constructed using either a tapered joint or a vertical butt joint. The tapered joint typically extends at a 12:1 slope ratio. In echelon paving, two pavers work side by side to eliminate cold joints and produce a more homogeneous mat. Final inspection focuses on key criteria such as mat thickness, slope, grade, surface texture, compaction, and overall geometry. All delivery tickets, temperature logs, and test results must be meticulously recorded to support quality assurance and eventual acceptance. Through proper coordination of material logistics, equipment operation, and quality control, the HMA paving operation ensures a durable, smooth, and structurally sound pavement layer. In Kyiv, Ukraine, the Tesmek 1150 XHD Rock Hog, a 50-ton surface mining machine with a 440 horsepower engine and 312 centimeters drum, broke 26 centimeters concrete pavement over 50 meters. Fragments under 150 millimeters were leveled, compacted, and achieved a 270 megapascals elasticity modulus. Hey! The restoration of the Ulsk Canal, situated approximately 20 meters below the groundwater table, required a specialized underwater rehabilitation method due to the impossibility of conventional dewatering techniques. Standard practice involving full canal sealing and excavation was not applicable. A custom fabricated platform was engineered using AutoCAD, based on precise canal cross-sectional profiles. The platform dimensions were approximately 35 meters in length and 1.25 meters in width, assembled off-site and transported for on-site deployment. The total operational length exceeded 40 meters with a structural mass of roughly 40 metric tons. The rehabilitation process utilized a crane system equipped with hydraulic articulated joints, allowing multi-axis maneuverability necessary to navigate the canal's curvature. Reinforcement mats were deployed along the canal bed at an approximate 13 degrees gradient. Concrete was pumped underwater into the mats via gravity flow, ensuring uniform consolidation and a seamless lining. This method permitted continuous underwater placement without dewatering, maintaining structural integrity and reducing environmental disruption. The hydraulic platform enabled precise positioning and alignment corrections throughout the procedure. Innovation isn't just about new construction. Sometimes it involves dismantling old structures safely and efficiently. PLATIO Solar Pavement combines innovative solar technology with durable paving solutions. Before installing PLATIO Solar Pavement, create a detailed plan and prepare a level crushed stone base about 5 centimeters deep. Installation is most efficient with a 2-person team. Insert cables as required, then place the solar pavers side by side, connecting spacers and wiring with cool splice connectors. Always connect red cables to black cables. Check voltage after each row using a multimeter. Once installation is complete, sweep the surface with wet sand and clean regularly. Connect the cables to microinverters housed indoors or in electrical cabinets, then power on and monitor performance via the app for optimal system management. At the end of August, Felbermayer's demolition department undertook the complex dismantling of a 52-meter-high chimney at the Vereinigte Fatty Products industry site in Wels, Austria. The chimney, over 100 years old, was no longer needed following the switch from oil to natural gas for heating. Due to spatial constraints and the desire to minimize dust pollution for nearby residents, conventional blasting was not an option. Felbermayr devised an innovative method, using an excavator suspended from a crane hook to carefully break down the chimney from the top. Initial meters were manually removed using a hammer drill, with workers elevated by a work platform. The chimney's walls consisted of 2 layers of brickwork, totaling 50 centimeters thickness. Before demolition, the chimney interior was cleaned of soot to prevent contamination of debris. Felbermayr's suction excavator was employed to vacuum the hazardous material. For safety, the site was reinforced with beams, covers, fleece layers, and straw bales to protect adjacent structures from flying debris. A customized lifting platform with attached supports allowed the excavator to operate safely while hanging from the crane. Water was sprayed continuously to suppress dust during the gradual dismantling. By late afternoon, the chimney was reduced to 8 meters, and the excavator was lowered. The remaining portion was demolished from the ground, with contaminated debris again vacuumed to ensure recyclability. Approximately 20 cubic meters of contaminated material were collected, analyzed, and properly disposed of. The entire chimney demolition was completed within 2 days, demonstrating Felbermayr's adaptability and expertise in challenging demolition projects. Large-scale demolition projects require careful planning and execution, especially for iconic structures. Maxwell Products Gap-Mastic repairs wide asphalt pavement cracks with superior flexibility, handling excessive movement. Ideal for fatigue cracking, depressions, and deterioration near drains, manhole covers, and gutters, delivering durable, versatile, and long-lasting pavement restoration. By understanding the fundamental building block of modern construction. Cement production. Cement production begins with the extraction of raw materials, and this first step is showcased at the Prokovice quarry, where surface mining is used to obtain stone for cement and lime manufacturing. The site mainly contains 2 types of rock, graphitic shales and limestones, with phyllites and lamprifier veins also present. These rocks are from the Paleozoic era, approximately 350 to 500 million years old, with the youngest being high CaO white crystalline limestone. Quarrying is divided into 6 current benches, with a 7th under development and 3 more projected. Bench heights range from 14 to 22 meters. Annual extraction was about 1.35 million tons, with reserves estimated for 90 years. Blasting is used to break the rock, preceded by drilling blast holes, and the drill cuttings are chemically analyzed via X-ray for planning purposes. Material is selectively loaded and transported by 60-ton dumpers to dedicated crushers. Crushed material is monitored and evenly distributed on pre-homogenization piles for consistent blending before further processing. The Eggborough Power Station's boiler house and chimney, iconic structures from the 1960s, were demolished on July 24, 2022, in a controlled explosive blowdown. The 50,000-ton steel-framed boiler house and 20,000-ton, 200-meter-tall concrete chimney collapsed in just 10 seconds, marking the final demolition phase after the station's 2018 closure. Executed by DSM Demolition, the operation used high-speed explosives within a 350-meter exclusion zone, ensuring safety with drone surveillance and road closures. The site, once powering 2 million homes, is now being redeveloped into industrial warehouses, symbolizing a shift from coal to modern industrial use.